You wake up tomorrow morning and decide to go for a run. Not a jog, not a sprint. You accelerate to 186,000 miles per second, the speed of light, the absolute speed limit of the universe. What happens to your body, to time, to the world you left behind? The answer is one of the most beautiful and most disturbing things physics has ever revealed. And it starts with a simple fact that shatters everything you think you know about reality. You cannot reach the speed of light. Not because we lack the technology, not because our rockets are not powerful enough, because the laws of physics literally forbid it. Einstein showed that as any object with mass accelerates toward the speed of light, its relativistic mass increases. Not metaphorically, actually, measurably. At 90% of light speed, your effective mass has already more than doubled. At 99%, it has increased sevenfold. At 99.99%, your mass is over 70 times what it was at rest. To push you that final fraction closer to light speed requires more and more energy, and the closer you get, the more energy is needed. To actually reach the speed of light would require infinite energy. Literally, infinite. All the energy in the observable universe would not be enough. It is not an engineering problem. It is a mathematical impossibility for anything with mass. But let us bend the rules for a moment. And imagine you could, somehow, travel at 99.99% of the speed of light, close enough to see what the universe looks like at extreme velocity. What you would experience is genuinely alien. The first thing you would notice is that the universe in front of you begins to compress. Objects ahead of you appear closer together, squeezed in the direction of your motion. This is called length contraction, and it is not an optical illusion. Space itself physically contracts along your direction of travel. At 99.99% of light speed, the entire observable universe, which is 93 billion light-years across, would appear compressed to a fraction of its normal size in your direction of motion. Stars and galaxies ahead of you would crowd together. Behind you, they would stretch apart. Light itself would shift in color. Stars in front of you would be blue-shifted, their light compressed to higher frequencies. Stars behind you would be red-shifted into invisibility. At extreme velocities, the cosmic microwave background radiation, the faint afterglow of the Big Bang that normally sits in the microwave spectrum, would be blue-shifted into visible light in your forward direction. You would literally see the Big Bang ahead of you, compressed into a blazing disk of white light. The rest of the sky would be dark. The universe would look like a tunnel of light that you are hurtling through at impossible speed. But the most profound effect is what happens to time. At 99.99% of light speed, time dilation becomes extreme. For every second that passes for you, approximately 70 seconds pass for someone stationary back on Earth. If you traveled for what felt like 1 year to you, over 70 years would pass on Earth. Your friends, your family, everyone you knew would age and die while you experienced a single year. And if you could somehow get even closer to light speed, the ratio gets more extreme. At enough nines after the decimal point, you could experience 1 year while millions of years pass on Earth. You could outlive civilizations, watch stars burn out, witness the geological reshaping of continents, all in what feels like an afternoon. This is not speculation. This is measured, tested, verified physics. Atomic clocks placed on high-speed aircraft and satellites show exactly this effect, just at much smaller magnitudes. GPS satellites have to account for relativistic time dilation to function accurately. The effect is real. We live with it every day. Now here is where it gets philosophical. From your perspective at near light speed, you are not moving through time faster. Everyone else is moving through time slower. Both perspectives are equally valid under special relativity. There is no absolute frame of reference in the universe, no cosmic clock that keeps the real time. Every observer's time is equally real, which means that time, this thing we structure our entire lives around, is not what we think it is. It is not a river flowing at the same rate for everyone. It is elastic, stretchable, personal. Your time and my time are only the same when we are moving at the same speed. The moment one of us accelerates, our clocks diverge, and they never fully agree again. There is another consequence of near light-speed travel that borders on the magical. Because your mass increases as you accelerate, and because energy and mass are interchangeable via Einstein's famous E equals mc squared, you would carry an almost inconceivable amount of kinetic energy. A single human traveling at 99.99% of light speed would carry kinetic energy equivalent to hundreds of nuclear weapons. If you collided with anything, the resulting explosion would be cataclysmic. A near-light-speed human hitting the Earth would release more energy than the asteroid that killed the dinosaurs. You would not be a person anymore. You would be a weapon of mass destruction, a relativistic kinetic impactor capable of sterilizing a planet. The speed of light is not just a speed limit, it is the scaffolding of reality itself. It determines how cause and effect work, how time flows, how energy and mass relate. If you could exceed it, which physics says you cannot, you would arrive at your destination before you left. Causality would break. Effects would precede causes. The universe as we understand it would stop making sense. The speed of light is the universe's way of saying that reality has rules, and those rules cannot be broken, only bent. And bending them reveals just how strange and beautiful the universe truly is. If you want to keep pushing the boundaries of what reality allows, subscribe. The universe has